All right, so let's start by graphing y equals cosecant x. We'll graph it really quick. Some of you already asked, does it work like it's the same relationship secant cosine that cosecant and sine have. And so you graph the sine.
This is a no calculator.
This is definitely a no calculator test, yeah. Let's see, we'll graph sine first. Sine starts at 0. This is a great reminder. Sine starts at 0. Here's how I graph sine when I'm graphing it without having seen it in a while. I know it starts at 0. I know its period is 2 pi. So that means it starts over at 0. And then basically in my mind I have the parent shape memorized. I know what the shape looks like. I know what a sine graph looks like. Just like you guys know what a parabola looks like. Like when you have to graph a parabola, you got to fiddle around and find a couple of points and get your bearings, but you know what it looks like. Same thing with sine. Like I know what it looks like. I get a couple of key points on there. Well, more than a couple. A sufficient amount, which for a sine wave is those 5 points. Well, they connect the dots, but with the sine wave, not a jagged wave. We almost always want 2 cycles of it, 2 periods of it. And it kind of depends on the problem whether you want to extend it forward or extend it backwards. Talk more about that today. So there's y equals sine of x. Now, when sine is 0, cosecant doesn't exist, right? Because you can't divide by 0. So wherever the sine graph is 0, there is an asymptote for cosecant. And then you just graph the u's off the top and the bottom.
Do we have to draw the sine, the wave part as a dotted line?
You don't, because they're so distinct and because it's so clear I know what you're doing. You don't have to take the time to like put in a dotted line for the sine graph. So anytime you want to graph secant or cosecant, you graph cosine or sine first, and then do the asymptotes in the u's. And then most of the properties we're not going to do those. You can figure them out if you need to. All right, how about questions from the worksheets? Although I'm not really going to answer questions 1, 2, 3, 4, 5, or 6 because that's the same thing. You already have those answers. That's just like more practice. That's like when you're in kindergarten and you're working on writing your A's and you write your A 10 times just so you kind of get the muscle memory of what an A looks like. It's like, yes, we already graphed sine. We already graphed all 6 of those. Do I need to graph them again? Yes, so that your brain and your hand gets used to seeing what they look like. But I will happily answer questions on the back. Although 7 through 12, I'll answer them, but that's just matching. And then 13, 14. So questions on the back, now that I've ruled out 12/14ths of the problems that I'll answer. Anything at all? Or any questions in general about shapes and what they look like? Yeah, 13 and 14 are pretty easy as well. Well, just to be clear. So 14, which of the ones have a period of pi? Which graphs have a period of pi? Tangent and cotangent, and the rest are 2 pi. So tangent and cotangent are the outliers. So 3 and 6. 2 pi is everybody else.